Welcome, everybody. You are in Catwoman. So that means it's going to be another Android session by Vitalek. Oh, goodness. Zasadnyy?
You spelled it almost properly. Okay, thank you for introduction. Hello, everyone. My name is Vitalek, and today we are going to talk about Gradle. But not actually about Gradle on Android, because everyone gets used to it. Everyone working with Gradle on Android since we have Android Studio, and it's kind of boring now, because it works perfectly. Today we are going to talk about something more challenging and different about applying Gradle on different platforms. But before we are going to start, let me ask you, who are Android developers? Okay, you got into the right room. And who is using Gradle for Android builds? Why not everyone? Could I ask someone who are not using Gradle why you are not using it? Anyone?
Legacy.
Okay. Legacy, yeah, that's a good point. That who has legacy projects and don't want to migrate, you don't have much chance. But for new projects, I really encourage you to use Gradle for everything. Okay, let's move on. A few words about who we are and what we are doing. I'm working for GetSocial. It's a Dutch startup. We are based in Den Haag. We are doing SDK. SDK that allows to add social tools to your game or application. It allows to easily add social feeds, chat, one-on-one chat, global chat to your game. It allows, it powers your smart invite platform so we can engage users, increase revenue, and stuff like that. And our SDK is available for 3 major platforms. And today we are going to talk mainly about Unity, because I'm Unity engineer. I do some stuff on other platforms, but mainly with Unity. A few words about our architecture. We have native SDKs written poorly on Java and Objective-C respectively. Our Unity SDK is exposed interfaces in C#, but basically it's a wrapper around native SDKs that forwards calls from C# interface to native implementation. And just to understand what were our problems, we have a lot of stuff to do. We have to build our native SDKs, include it into Unity SDK. We have to build apps, like the same common problems that everyone has in their daily job. And here are tasks that we had to automate, like building SDKs, building test apps, generating artifacts, and running all integration, unit tests. All the stuff need automation. It's possible to do it manually. We've done it for quite a long time, but time can change, and we grow enough to automate all the stuff. I joined a company at the beginning of this year, and when I joined the company, we had the following setup. For Android builds, we had obviously Gradle. We also supported Eclipse, but let's not talk about that sad part of our history. For iOS, everything was automated with Bash scripts that were plugged into Xcode build lifecycle. And the worst part is Unity. We had kind of Bash scripts that automated some tasks, not everything, but Unity changed quickly and no one supported that script, so they were outdated and we had to do everything from scratch and manually. It was kind of painful, and we decided to redesign all our build pipeline to new build system. And we put in front of us several requirements, how we see our future build system, build pipeline. First and main requirement was we want all these build scripts written in one language. It's easier to support, it's easier to integrate with each other, especially for Unity builds, where we need, before building Unity SDK, we need to build all native SDKs. And we don't want to do it manually, so we have to automate it. And with one language, it's easier. We need to be cross-platform. In case of Unity, it's much easier to work on Windows, because on Unity you write on C#, and as far as I know, there is no good IDE for C# on Mac OS X. If someone knows, talk to me.
Have you tried Visual Studio Code?
Yes, I tried, but it's terrible with Unity. It's good. I'm pretty sure that at some point it will be a real good IDE.
But Unity has also mono.
Yes, it has mono, and that's very painful, because it doesn't work. Especially, like, in the latest versions, they fix a lot, but half a year ago, you even were not able to refactor properly. It's out of our topic, but one funny thing about MonoDevelop, they had nice issue with nice memory leak. If you search a lot or just navigate between files via like searching for them, like 3 files and it's out of memory. So that's the state of C# development on Mac OS X. That's why some Unity developers prefer to work on Windows. So we had to support cross-platform scripts. We wanted our SDK to be built with, we want our build scripts to be written in some language that is pragmatical. No XML, no crazy stuff with that varied language that no one knows. It should be something familiar for everyone, or at least more or less familiar. And it should be powerful. Besides basic build tasks, we want to automate more complex behaviors like database migrations, interaction with external APIs, and stuff like that. So we looked into market. What do we have at that moment? Of course, we have Ant. Who still works with Ant? That's good. Probably it's more part of legacy project. Actually, we didn't consider Ant as an option, just I wanted to know who is still working with that. Second option was Bash. Bash is quite good because you can automate pretty anything. It's console build scripts, it's pragmatic, you can automate everything. It maybe not, it doesn't support like object-oriented programming or functional, but you can do pretty everything. It's good. Main problem for us with Bash was cross-platform support. It's possible to run it on Windows, but Cygwin is like not so good and it's not native support, so we decided to give a try to Gradle. And Gradle in terms of cross-platform is great. Like you can write everything. Gradle abstracts all interaction with the underlying system from you. It's for Gradle scripts you use Groovy. It's object-oriented language. It's basically Java on steroids. And dynamic, so it's cool. It suits perfectly our needs, so we decided to give it a go. And let's see how it goes, integrating Gradle with other platforms, because we have to support Android, iOS, Unity. For Android, obviously, everything works perfectly. We have Android Studio integration. It's integrated with IDE. It works perfectly. Plugin is excellent. It's tested. It's supported by Google. The life is nice. With iOS, it's kind of the same. We have maybe not official plugin from Apple, but it works. OpenBakery did a great job about that. It's not integrated with Xcode or app code, but for our tasks, mainly for CI, it worked perfectly. Like you configure, you have similar domain-specific language as for Android. You configure all parts of build and just run. Everything works. The sad story was about Unity. There were no plugin on the market. There were no community. Even if you search for tags Gradle and Unity on Stack Overflow, probably you won't find much about it. So what we have to do? The main thing is not panic. As with any build automation, if we have any kind of interface exposed via pragmatic API or command line or whatever, we can automate it. In case of Unity, we had command line interface exposed. It may be not very powerful. We cannot control every part or every aspect of build process, but it's powerful enough to launch, to invoke any public static method on C# side. And from C# you can control all aspects of build. So we had a plan. We are going to collect all required information on Gradle side, put it into nice object, and push everything to static C# method. For the first iteration of our Gradle build automation on Unity, because like iOS, nothing interesting. Like I described most part of it, so we are going to talk about automation in Unity. We defined several tasks that we want to automate. Mainly, it was building, running unit tests, and pushing test apps for beta distribution. like all the things that we face in everyday development, but not crazy stuff like integrating into different environments and database migrations. We decided to start with something simple. At the end, we automated builds, we automated our unit integration tests, we automated beta distribution, like pushing after CI build everything to hockey up. Everything worked really great, and it was just like 600 lines of code. It was pretty good, not so much. It's not a messy code for like 1,100,000 of lines. It's very easy to read because it's Groovy. It's not XML. So it was good. Now we are going to talk which Gradle features we use to optimize that, and look like the main purpose is I want to show you that you need to use only a few features to make really powerful stuff. And first, the basic feature is local variables. Like everyone is using local variables, and you have local variables in Gradle. Basically, as the same as in Java, you can define variable, use it in task, nothing special. One thing about variables, just to remind, it's not a Gradle feature, it's basically a Groovy feature. And because it's Groovy feature, all variables have exactly the same behavior as in any programming language. They are scoped, so if you declare them in one scope, they are available only in that scope. Why it's important? Because there is other option. For similar purposes, we can use extra properties. It's basically variables that are attached to some Gradle object. We can attach properties to any Gradle object that is extension aware. Basically, it's project, task, any configuration, like almost all Gradle DSL objects. And it's not a Groovy feature, it's a feature of Gradle. As I said, it's available to all Gradle objects that are extension aware. It's interface that this object have to implement. And these properties are available globally. They are part of Gradle object, not some certain scope. So you can access them from anywhere in your build script. A few differences between variables and properties to understand. Variables are part of the scope. You can use it for, like, in methods for processing. And they have local accessibility. If you need something for configuration or to expose for external world, you have to use properties. That's it. So we need to configure stuff like SDK version to build with, for which platform we are building, which project, in which folder our project is located. So we have to use properties for that. For any local computations inside tasks or methods, we have to use variables. Okay, let's move on. Next feature is obviously tasks. Task is a set of work that Gradle can perform. This task is exposed to command line. So if you define some task, you can invoke it from command line, and this part of work that you described will be executed. Tasks can be chained. Basically, you can define that this part of work can be executed only after. I have to talk this way. This part of work can be executed only after Android sample will be executed. It's some kind of task chaining, but be aware that if you define things like this, if you chain several tasks, Gradle do not guarantee that will be executed exactly in order you defined, but it's possible to fix. You can define methods like this, like that. Takes to which task you have to want to attach dependent tasks, and with simple for loop you will define which task should run after each. So with this example, I want to show that if Gradle is missing something or API is not so convenient, you can easily extend it. So maybe Gradle engineers not ideal in defining all APIs, but if they do something wrong, we can easily fix that. And it's not the case with some different build platforms. And to invoke it, you can call something like this. You can extend existing tasks. In our case, we needed to invoke Unity command line tools. So we can use execution task, just extend it, provide which command line to to execute, which parameters to pass, and we are good to go. Besides extending execution tasks, we can extend, there are tons of different, for Java compilation, packaging your libraries, deleting folders, pretty everything you can imagine from basic stuff is already available on Gradle that you need just to configure and run. Yes, please.
In the case of chained tasks, how do you handle a task failing?
We fail all build.
Okay.
Because it doesn't make sense to continue build if some part is failed. At least we suppose like that.
Okay.
And you can create tasks to extend. There are tons of tasks defined, but if you need something really specific, you can just create Groovy class that extends from default task and define all your behavior there. We use build types. You Android engineers, you probably know what is build types. Build types are were not natively supported by Gradle up to version 2.7, as I remember. They are still incubating feature. We didn't use native build types because there were no much documentation. They were still incubating. We used custom implementation, but idea behind is exactly the same as on Android. That's one more example that if Gradle is missing something, you can easily extend it. And we are going to switch to native implementation probably. We will definitely switch in the next iteration. And when we finished first iteration, everything was good. We were running all builds on CI. We had all tests running automatically, building automatically, distribution automatically. All was good. All was good. But later we needed to add more tasks. And we decided, it's better to split our huge build Gradle file for 600 lines into some smaller pieces, as it's hard to support. And we defined our main problems. From first iteration is, we had too big script. We repeated some parts of code, especially in terms of running and building test applications for different platforms. And we wanted to separate related tasks into some groups, not to keep everything in one file. At the end, we expected to have exactly the same set of features, but separated more properly. We ended up with something like this. We had 6 Gradle files, 5 for features and 1 main build Gradle files, and we also moved some logic to Groovy. So how did we do that? If you want to split tasks, move into a separate file, you just move everything related to that into a separate CI Gradle file or whatever Gradle file, and include it into your main Gradle file. Just keep in mind that all methods from this Gradle file will be available after apply. So don't forget to apply your included projects at the beginning of your main build Gradle file. As I said, we split our 600 lines build file into 6 ones. We separated logic into continuous tasks related to continuous integration, to beta distribution, and stuff like that. But we got small drawback. We had helper functions that we used in several tasks, and now it was not so easy to use them. So we just moved them to Groovy. It's easy. Gradle has special folder for Groovy files. It's build src. If you want Groovy scripts to be included into Gradle build, you have to put them into build src folder and then default Gradle configuration. Besides writing files in Groovy, you can use Java. Then just put files instead of Groovy in Java folder. The good thing about Groovy is it's almost Java. If you know Java, I suppose you know Java because we are Android developers. You can write in Java, and if something will go wrong, Android Studio will help you with that. But I really recommend to look into Groovy's syntax. It saves you a lot of time, especially with boilerplate. And when you are ready with writing your Groovy classes, just include it into your main build script, but instead of using apply plugin build file name, import it just like you are used to import files in Java. and use it. Basic. Nothing special, but saves a lot of time, and like it's kind of object-oriented programming, you know? We can apply the same best practices of software engineering that you use in your everyday development to build scripts, which is what was not possible with Ant or Maven or any kind of that era of build tools. And now we are on third iteration. Now it's kind of delayed, because we are focused on a release of new version of SDK, but we have plans. And our main plan was to split our build file even more. We want to define the same concept as Android have. Like now we already have build types. We want to add flavors. Now our build types have different build types are reserved for different environments we build to. Like we have testing, staging, and master environment. We want to include flavors that will be responsible for public and internal test apps we have. We want to expose configuration DSL, because for now all project configurations are done via project properties. It's just a huge bunch of properties, like 10 or 15 properties. They are flat, they are not grouped. We want to do something like this. You see something familiar? Kind of Android build, right? The only difference, we define Unity at the top. So basically what we did, we just looked into our Android plugin. It's amazing, it works great. They designed everything we need and just adapted for our needs. And defined domain-specific language for Unity builds, but with names more familiar to Unity developers. If you want to create plugins, basically what you need to do is to extend one interface with one method apply. Gradle don't put any restrictions on how you should define your plugins. You can create plugins almost for everything. You just, like the most common one is obviously project file. Like you can create plugin for a whole project, but you can create plugins for tasks, source sets, pretty anything you can imagine. And then you just apply this plugin to your build Gradle file. In order to define domain-specific language, you have like this funny things that we saw with Unity on top. You have to create simple, plain old Groovy object and define all fields that you want to configure, and just say that I want to be able to configure these properties under this name in my project. That's all you need to do. That's it. It's very basic. It couldn't be even simpler than this. There are like small caveats. How you are working with nested objects, but you can read that in documentation. There is nothing special. And then just configure everything you want in your build Gradle file. A few things that I want you to take away from this presentation is, in modern fast-moving world, if you want to deliver really high-quality product and on a big scale, and you want to move really fast, you have to automate. You have to automate as much tasks as possible, and Gradle is first-class citizen in build tools environment. When we are using Gradle, we are writing on Groovy, maybe on Java, but mainly on Groovy. And when we are writing on Groovy, we can apply all best practices for software engineering we all know. Like we have to keep our code dry. We have to separate our concerns. Basically, we just have to do our work. We don't have to learn something crazy specific about build tools. We just have to do exactly what we know, but for a building. And use Gradle features. It's really easy. Like creating plugin, it's extending one interface. It separates your logic. You can share your plugin with everyone else later on. And it's very easy. As I showed you, it's like 5 slides. Now you can create and automate pretty anything that exposes any kind of interface. And to finish with, I'm really excited to announce that our Unity Gradle plugin will be open sourced. It's the first Unity plugin available on the market for Gradle, and it will be open sourced as soon as we will decide it's good enough. But it will be soon. For now, thank you for your attention. If you have any questions, feel free to ask. I suppose we have quite a lot of time left. So thank you. Any questions? Yes, please. The question is, why me as Android developer, I have to use Gradle plugins? You mean what extra plugins for Android developer? Okay. Let's take, for instance, continuous integration for Android. For continuous integration, like most common tools like JUnit Runner, but they included in Gradle, for instance, integration with Sonar that aggregates results of all tasks, of all testing. If you want to see a big picture of all your testing that you apply to your project, you can just apply Sonar plugin, configure it where, like, how reporting should work, like which plugin from where to get sources, and like with 5 configuration lines, you can get nice statistics from all your build automation. It's very convenient, and like when I started to work with Maven, I thought it's amazing. After Ant, Maven was like concept of plugins where you can configure like 50 lines of XML code. It was amazing, but with Gradle it's even easier, and it's much more declarative. So, with Gradle, like, there are more and more plugins appearing on the market, and I'm pretty sure if you're working with Android, if you want to do something, there is a plugin for that. If not, go on, create one. Yes, please?
How did you convince iOS developers to use Gradle?
That's the tricky part. To be honest, we had a long conversation about that when we selected which tool we have to automate, which tool we have to use to automate. I don't know. Like, we had a long conversation, and we decided, yeah.
No fights.
Like, no one got into hospital after that. Yeah, but the main concern was when we are building Unity, it's the hardest part of our build pipeline. We need to use some unified tool. Of course, we can call Xcode build targets from Gradle, like from Unity build. But why do we need to do? Like, why do we need to put logic for building iOS project into Unity build plugin into Unity build code? So we just moved it into Xcode. Actually, on CI, on our Jenkins, iOS is still built it with bash scripts. Just for Unity integration, we use Gradle part. Any other questions? Yes, please.
Mike. Yeah.
Cool, thanks. Your open source Unity plugin will it include also installation of Unity?
Once again, could you please repeat?
So I have a plain empty machine. I download your sources and I run Gradle. So do I need to install Unity manually, or this will be included?
Yes.
Here?
For now, workflow is like that. You create Unity project. You go into your root directory of Unity project. You type Gradle init or Gradle wrapper, and it creates basic wrapper. Then you, like, for now it's just a set of build scripts. It's not published online, but later on you will just have to define repository where our plugin will be available. Call apply something Unity plugin, and you're good to go. You will get all tasks available in your build script from our plugin.
No, the idea is like I'm new to Unity or to your new project, so I just download your sources, run, and is it. So I don't need to do any manual job.
You still have to download Unity.
Okay, it's not possible to automate.
It's not our target, let's say
Okay.
like that.
Okay.
Like with Gradle, everything possible, but with Unity, you have to, like, Unity is proprietary product. Like, since Unity 5, you get all the features for free, unless your published game has 1,100 users. But, like, we don't targeting that, like, absolute automation. It's too much. Yes, please?
The advantages of this thing, basically, we have already CI integration. Okay, I use Jenkins and OKFs for my deployments.
Mm-hmm.
And Gradle is just for creating my builds. So what are the advantages over the current system that we are using for this particular thing?
So the question is, you are using Gradle for deploying to Hokia.
We are just using Gradle for creating a build.
You're using Gradle for creating a build, and
Deployment and other things, we are using Jenkins.
okay,
It's open source tool. So what are the advantages of?
yeah, I got a question. So the question is, guys are using Gradle only for building your application, as I understood, and the rest of automation, like deploying to for beta distribution and running unit tests, are performed by Jenkins. We had kind of similar setup for Android, but now everything is done from Gradle because you can run it locally. For instance, if I need to deploy quickly beta distribution with some fix to our testers, I don't have to push everything to develop. Like in our current setup, we are building Jenkins builds only from develop. If I'm working on a feature branch or some bug fix branch, and I want to deploy a beta build for our testers, I want to deploy everything to Hokia from local machine. And what I need to do, I just type Gradle, deploy to Hokia, and all done. Like 3 minutes, and everything is deployed to Hokia.
From your machine?
Yeah, from my machine. And on Gradle, on Jenkins, if you want to migrate to different CI, like you will have to reconfigure everything. If you automate everything with Gradle, you just move everything to a different CI environment, and like, invoking one task on Gradle is much easier to configure than invoking everything, like setting up all unit tests and stuff like that. So we prefer to keep everything in one place and not to be binded to one CI tool. Because we don't, like now we are using Jenkins, but there is chances that we are going to migrate to something different. You never know. Any other questions? Okay. Oh, yes,
One
please.
question. I'll give you the mic, though. I'll give you the mic.
Do you guys use any UI testing tools like Calabash, and how? Can you tell us a bit more about the story between how Gradle comes into the picture with?
Yes, sure. About UI testing, are there any automated testers? We are hiring.
Nicely played.
Actually, that's true. Like we are hiring a build automation engineer because we want to automate our behavioral tests. Now we have unit tests, like low level. We have integration tests to test our public API. And we started working with Appium for behavioral testing, but we lost our QA engineer recently, and the work was stopped like somewhere at the beginning. So we are looking for someone else, and when we are going to finish that story, I'm going to prepare one more presentation about automating and that stuff. But it's one more challenge that we are going to work on in the very near future. Okay, if there is no questions, once again, thanks for attention. Follow me on Twitter. It's not visible, but you can find me. And here are next speakers. Don't miss their presentations. Thank you.
Okay, great. Thank you so much, Vitalek. We're going to have lunch in just a